Hi, guys. I am not in class today again. I am so sorry, but today you should have taken your first quick check, and I hope it went really, really well. Tomorrow, when I get back to the building, I will take those in home with me and grade them. So you will have them back on Thursday before you leave for your 3-day weekend. So, first off, today we are kind of moving on from some of our area of triangles, our law of sines, law of cosines, and we're going to go back to some trig functions. So, on Google Classroom, you have a fresh copy of this, what I like to call it like cheat sheet. It is our trig notes for Unit 2. And really, today we are going to focus on these 6 trig functions with our simplifying trig expressions. Now, as you can see, will get into something called trig identities a little bit later and Pythagorean identities. And we'll get into that when I get back to the building tomorrow. But this video is going to be short and sweet. You should be following along in your homework notes that looks something like this. It is 2 pages. And really, we are just going to do a few examples together. And then your goal is just to finish this on your own for tonight, or at least just try it, right? Tomorrow when we get back to school, we will kind of start fresh from a good basis. But at least if you watch this like short 10-minute video, you kind of have a good understanding of where we're coming from. And so it would be a good idea to have this open in another tab just to kind of remind ourselves, sine is the opposite over the hypotenuse. Cotangent is the adjacent over the hypotenuse. But then also, when we talk about trig identities, remember tangent is sine over cosine. Remember, cosecant is 1 over sine, cotangent is 1 over tan, or cosine over sine, right? You got to think about some of those pieces. So really, today when we talk about simplifying trig expressions, we're just going at it at the basis of like, this is where we're going in the future for the next week and a half. Miss Shaw is out today still, so this video is just going to be previewing it and introing it. By no means should I expect you to master it for tonight. So again, today is just more so practicing and kind of getting a feel for where we're going. If you can complete the homework, awesome. If you can't, just try it. So with that, let's go ahead and we are going to take a look at this worksheet. So first off, when we simplify trig expressions, the overall goal for us is to finalize our answer in one single expression. If you take a look at this first example, we have the cotangent of theta times the sine of theta. And even though this is a product and those two are being multiplied together, that's still not a single simplified value. Now, sometimes as you see in the directions, we may get a numerical value. Sometimes when we simplify, we'll just get a single trig function value. So like the cosine of theta or the sine of theta. Now, remember, when we simplify, we may not always get it narrowed down to like a singular piece. That's always the overall goal. But really just can we express it in the fewest number of terms as possible? So let's get started. First off with number 1, we have cotangent of theta times the sine of theta. And sometimes when you actually physically put that multiplication piece in the middle of it, it does make it a little bit easier to see it and deal with it. Now, first off, sine is sine. It's like one of the OGs, one of the original 3 that we learned right off the bat in the beginning, even from geometry. But cotangent is not. Cotangent is 1, a reciprocal trig identity. We can say that cotangent is 1 over tan, but really, if you were to write 1 over tan times sine, that does not get you very far. Instead, we can view cotangent as the cosine of theta all over the sine of theta. And if you take a look back at our little cheat sheet that I thought I had right next to me, but I guess it was underneath, we see that right there. Cotangent is the cosine of theta over the sine of theta. So now, if we take a look at that, the cosine of theta over the sine of theta, that's still being multiplied by the sine of theta. And if you want to put it over 1, you can. But really what this turns into is, if you notice, you have a sine on top and a sine on the bottom, and anything that's being reduced, simplified, anything that's 1 on top, 1 on the bottom, remember, that's just fancy 1. Anything divided by itself is just 1. So our sines ends up canceling out. We're left with the cosine of theta over 1, which really is just the cosine of theta. And if you think about it, that is as simplified as it can get. Cosine is one of the original 3 trig functions. So that's it. It's just a singular cosine. So as you can kind of see, our objective here is to always break apart this expression and kind of knock it down a little bit. So let's take a look at number 2. The tan of theta is being multiplied by the cosine of theta. So let's go ahead and let's split this up. The tan of theta times the cosine of theta. And now, just like what we did last time, it's going to look pretty similar, but obviously with a different outcome. The cosine of theta is one of those original 3 trig functions. Sure, the cosine of theta could also be thought about with the reciprocal of secant, but we don't really want to use that reciprocal unless we really have to. So let's talk about the tan of theta. Tan of theta is also known as sine of theta over cosine of theta. And once again, hopefully we see that cosine over cosine is just 1, so we can go ahead and cancel those out. And therefore, we're left with the sine of theta over 1, which is just equivalent to the sine of theta. Okay, let's bounce around a little bit. Let's take a look at number 5. So again, your homework, just try 3 and 4. You can check the key. I will post it on Classroom. But again, like I said, if we're lost, please don't worry. This is just for us to kind of scratch the surface, get a good base understanding, and just really learn about where we're going for the next week and a half. All right, so first off, when we talk about sine in terms of a fraction, we have sine over tangent. Okay, well, we could break this up into the sine over 1 times 1 over tangent, but, that doesn't really get us anywhere. So let's kind of play around with what tangent is. Remember, tangent is the sine over cosine. So if you think about it, that is the denominator, and the sine of theta is still our numerator. So yes, this is a complex fraction, and we really try to avoid complex fractions. But if you think about it, what do we know about a complex fraction in your denominator? We can always multiply by the reciprocal. So let's take a look at this. We can keep our numerator the same, the sine of theta. And now we can bring this denominator up to the top and multiply it by our reciprocal. Well, our reciprocal would be the cosine of theta over the sine of theta. And if you take a look right here, sine is in the numerator, sine is in the denominator. We can cancel those out. And our final answer is just the cosine of theta. So like I said, these are kind of just like puzzles. You kind of have to piece apart what works, what doesn't work. Sometimes you could be falling on the right track and then get into like some type of rabbit hole and get a completely different answer than you thought you would just because of the simplifications. Now let's take a look at this next example, number 6. We know number 6 is the cosecant of theta, so that's the reciprocal of sine. And we know the cotangent is in our denominator. So sometimes you'll notice that we like to break these apart. Division is really just multiplication. It's the multiplication of the cosecant over 1 times 1 over the cotangent. Now, that doesn't really help us at all Cosecant is 1 over sine. Okay, we could potentially fool around with playing with that. And okay, 1 over cotangent is just tangent. And tangent's one of those 3 originals. So let's change that to tangent first. Tan of theta times the cosecant over 1. Now, when we talk about tangent, we see that, okay, tangent is sine over cosine. Well, we don't really have a sine anywhere right here. But we do know that cosecant is 1 over sine. So maybe that might help us. Turn cosecant into 1 over the sine of theta. And then we could turn tangent into the sine of theta over the cosine of theta, which if you take a look, sines cancel out, and we're left with 1 over the cosine of theta. Now, we want to try and avoid leaving our answer as a decimal, or not a decimal, a fraction as much as possible. We know that 1 over cosine is the inverse of cosine, and we know that that is just equivalent to the secant of theta, and that is your final answer. So if we take a look at this second page, we do have a few more problems. You know what, you guys? How about this? Let's say that our homework for tonight is only the first page. So I would just really like you to try 3 and 4 on your own. Please don't worry about 7, 8, 9, 10, and 11. We're going to save that for when I get back tomorrow in class, because if you notice, it deals with some trig functions that are squared. And that's going to deal with these, which I highlighted, these Pythagorean identities, which we can kind of use and manipulate just like the law of sines and cosines to work with what we're given. So let's just pause on that. So your homework for tonight is just that first page of the homework worksheet. So numbers 1 through 6. And if you think about it, we did 1, 2, 4, or 5, and 6 together. So let's just worry about 3 and 4 on your own, and then you can check your answer with the key. All right. So other than that, I will see you in class tomorrow. I have missed you guys so much. I hope your quick check went well today, and I will see you all later. Goodbye.